electrochemistry class. In this class, we are going to discuss the basic concepts of electrochemistry. Now, let us see the terms resistance and conductance of a substance towards flow of electric current. Okay. Let us see what is resistance. Resistance. Resistance is a property of a substance to restrict the flow of current, electric current. Okay, that is said to be resistance. A property to resist flow of electric current. Okay, so in case of electrochemistry, the resistance is to be considered as electric resistance. Okay, now let us see. Resistance can be denoted by R. Okay, so when you consider R, it is a reciprocal of conductance. Reciprocal of conductance. Okay. So units for resistance is ohm. Units for electric resistance is ohm. Okay. Now let us consider what is conductance. Conductance. Okay. It is reverse to resistance. Okay. So this can be defined simply as reciprocal of resistance. Okay. Let us see the definition. A property to conduct. Okay. See the difference here. Here to resist, here to conduct. To conduct flow of electric current. Electric current. Okay. So, being it is quite opposite to resistance, so the conductance, if you consider conductance as C, conductance is equal to 1 by resistance, 1 by R. So then units for this is 1 by ohm. It is also called as ohm inverse or mho. Okay, the another unit is Siemens. This is also unit for conductance. Okay, so in next video we'll go through the other basic concepts which are related to resistance and conductance in detailed manner. Thank you. Resistance. Specific resistance. If dimensions also specified in the definition, the resistance is termed as specific resistance. Okay, let us see what will happen. So here this can be defined as resistance of a substance having unit length L. Is it clear? And area of cross section A is said to be specific resistance. Resistance of a substance having unit length L and area of cross section A is said to be specific resistance. This is also oftenly called as resistivity. Okay, so it is denoted by rho. Is it clear? So it can be either mathematically, it can be represented in terms of resistance. We know that resistance indicated by R into A by F. A by F. Okay. So as we know that the units for resistance is ohm and area of cross section meter square and length m. The units for specific resistance or resistivity is ohm meter. Okay. So this is about specific resistance or resistivity. Is it clear? Here also we can say that if conductance is incorporated, includes the dimensions or specific dimensions of substance, then the conductance is said to be specific conductance. Oftenly this is called as conductivity. Is it clear? So now let us see the definition. Conductance of a substance with unit length L and area of cross section A. This is said to be specific conductance or conductivity. Okay. So this can be represented with the Greek letter kappa. Okay. Kappa is the unit for specific conductance. Okay. If you consider conductance as C, okay, then specific conductance can be represented kappa is equal to C into L by A. Okay. As we know that the SI unit for conductance is ohm inverse. So for C ohm inverse we have to take and meter by meter square. Okay. Now let us see the SI unit for kappa is ohm inverse meter inverse. Is it clear? But the CGS unit for conductance is Siemens. Specific conductance is Siemens centimeter inverse. Okay. This is SI unit. This is CGS unit for specific conductance, which is often called as conductivity. Okay. Thank you. Molar conductivity. Okay. See here, if you mention the concentration of the electrolyte, then it is to be considered as molar conductivity. Okay. See here the definition for that. Molar conductivity. So simply we can define that conductivity of a solution with 1 mole electrolyte, is said to be molar conductivity. Molar conductivity. It is denoted by lambda m. Okay. So we know that the specific conductance and conductivity represents the same meaning. Okay. So now kappa is the representation for conductivity. Okay. And then the concentration of electrolyte is C. So molar conductivity can be represented like this. Conductivity divided by C. So here, since C is proportional to 1 by V, we can write this as lambda m is equal to conductivity into V. Conductivity into V. So when you consider with the dimensions of molar conductivity, lambda m is equal to, so we know the units for conductivity. Now let us go to CCS, Siemens centimeter inverse. This is CCS unit for conductivity or specific conductance. See here, volume can be represented like centimeter cube. Okay. And finally, we can get the dimensions for delta m is Siemens centimeter square. We are taking here 1 mole substance, mole inverse. Mole inverse. Is it clear? So we are taking 1 mole. Okay. So this is about molar conductivity. Molar conductivity. Equivalent conductivity. Equivalent conductivity. So see here, very simple it is. Conductivity of a solution or an electrolyte. A solution or an electrolyte. Okay? A solution with 1 gram equivalent electrolyte is said to be equivalent conductivity. Okay. So equivalent conductivity oftenly denoted by lambda E. Okay. So now let us see, as we know that conductivity equal to specific conductance. So now we can represent lambda E is equal to specific conductance kappa. Specific conductance or conductivity kappa divided by concentration. Okay. Since C is proportional to 1 by V, lambda E is equal to K into V. Okay. So being 1 gram equivalent, it is no need to represent about equivalent. So now here, then let us go through the units. We know that for kappa, the CCS units are Siemens centimeter inverse, and for volume centimeter cube, and because of 1 gram equivalent in the definition, equivalent inverse. Okay. See here, the units for equivalent conductivity is Siemens centimeter square equivalent inverse. Okay. By drawing units for any specific property, we can define that also easily. Okay. Thank you.